just as if you guys were trying to add and subtract variables, they have to be like terms. When you add and subtract radicals, they have to be like terms. So you guys would know not to try to add 3x plus 5y because one's an x and one's a y. Well, same thing goes with radicals. Unless they're both the same root and the same value underneath, like it has to be the exact same, you can't add them together. So what happens is we need to simplify them and then hope that when we're done, they are like terms and we can combine them together. So for number 7, it doesn't usually happen this way, but these are both cubed root of 12s. So you've got 4 cubed root 12 minus 1 cubed root 12. So what happens is you subtract the coefficients. 4 minus 1 is 3, and keep everything else behind it. So we say, how many cubed root 12s do we have? 3 of them. So this piece here is what stayed the same. We just said how many of them do we have. So for number 8, the square root of 108 and square root of 75 are not the same. So we have to simplify them both and hope that when we do, they're alike and we can combine them. So 108 would be 54 and 2. 54 could be 9 and 6. 9, 3 and 3, 6, 2 and 3. So again, it doesn't show it, but this would be a square root. If you don't see a root, it is a square root, which is 2. So groups of 2 things. So we have a group of 3s and a group of 2s. This guy is left by himself. So 2 times 3 is going to be 6 outside, square root 3 left. Let's simplify 75. 25 and 3. 5 and 5 group. What is left? So 5 outside, square root 3, bring down the minus sign. So this worked out. We both of them ended up as a square root of 3. So how many square root 3s do we have? 6 minus 5 is 1, square root 3. That's it. So let's do number 9. Our coefficients are really the 7 and the 4. So we're sort of saying how many 9 to the power of 2/3 do we have, because they're exactly the same. So 7 plus 4 is 11 of these 9 to the 2/3. But just like you can't have negative exponents, we can't have exponents that are fractions. So we're just going to rewrite 9 and 2/3 in radical form. So 11 times the cubed root of 9 squared. Can't have exponents that are fractions. So 13 and 14. Let's actually do 14 first. So 15 and 8 are the coefficients. So looking at what is behind those coefficients, are they exactly the same? A to the 4th times b to the 2/3. A to the 4th times b to the 2/3. They are. So how many of these things do we have? 15 plus 8 of them is 23. So we don't add the exponents. We don't say this is a to the 8th. We just say how many of them do we have? 23, a to the 4th, b to the 2/3. But you can't have exponents that are fractions, so we will just rewrite the square root or cubed root of b squared. We will rewrite b to the 2/3 power. Okay, so how about 13 with our variables? Same idea. The coefficient in the second one is 1. The coefficient in the first one is 10. If what's attached to that 10 and the 1 is not exactly the same, then we have to simplify this. So just do one at a time. So ignore this one and do the first one, and then switch it, ignore the first one, do the second one. So for the first one, 10 times the square root of 5s to the 7th. You can't factor 5 at all, so 5 is just going to stay underneath the square root. But what about s to the 7th? This is a square root. So how many times does 7 go into 2? If you wrote out 7 s's, how many groups of 2 do you have? What is left? So 3 groups, so s cubed outside, 1 s left underneath. Bring down the minus sign. So then we've got s times the square root of 80s to the 5th. So 80, we can find a square in there, so let's factor 80 out. So let's do 10 and 8, 4 and 2, 2 and 2, 10 is 5 and 2. So again, we don't use what we factored, so we have a group, so 2 times 2 is 4, with 5 left underneath. That's good. We want 5 and 5. The first one had a 5 underneath the root, so our second one should have a 5 under the root. Now let's do the s's. So s to the 5th power. How many times does 2 go into 5? If you do 5 s's, 1, 2, 1 left. So 2 s's, 2 groups of s's, s squared plus the 1 s that was already out there makes this s cubed outside, and this 1 s left underneath. So now what's attached to the 10 and the 4 is exactly the same. I think it's kind of uncomfortable to read and to write out, but we're saying how many s cubes times the square root of 5s do we have? Well, 10 minus 4, we have 6 of them. So that is our simplified answer.